So the idea of this video is just to tell you a bit about the application developed under the QGenome project and to actually show you a short demo of this application. The main aim of the app is to privately compute phylogenetic trees. So, and in order to do it, we will use secure multi-party computation assisted with quantum technologies. Has building blocks. In order to do this, has building blocks, we need two quantum communication systems, a quantum key distribution system and a quantum oblivious key distribution system. But for the case of this demo, we will just use a simulator, in this case called LKMS, which stands for Light Key Management System. And this simulator will basically distribute all these keys through the several parties. In our case, in this case, we will have three parties: Alice, Bob, we could call it, and then Charlie. We'll have here three parties. Besides the simulator, we will also use libscap implementation of the YAO protocol, which basically lies here inside this SMC engine. And we'll also use a tool, the CBMC GC tool, to generate Boolean circuits. So basically this CBMC GC tool has input a C++ or a C file and outputs a Boolean description of the function that the C file computes. So, and then the libscap implementation of the YAO protocol uses this Boolean circuit generated by this CBMC-GC tool in order to actually compute the function that we want to do privately. Then, finally, we kind of integrate all these tools with the Philip package, which basically is a C++ open source project that provides a set of programs to inferring phylogenies. And in our case, we want that to compute phylogenetic trees. So let's start the demo. And first we have to start the simulators in both three parties. So it's running. And then we can launch the application. Okay, so now Alice can start the computation, and here in the application we have several options. Basically, we have four options. We have a local computation of the phylogenetic tree, where we just use local sequences. Then we have a classical multi-party computation, where we actually compute the phylogenetic tree between sequence from the three parties. But in this case, they will not be private. And then we have these two last, which basically we compute the phylogenetic tree privately. But in the first case, we just use classical tools. We just use classical cryptography. And in the second case, we actually use quantum cryptography. So we will go for the last one, where we use quantum tools that will assist us in the computation. And basically Alice gives a name to the final file, selects, for example, two sequences, selects the method used for the computation of the phylogenetic tree, and invites, in this case, two parties. Okay, she invites, they receive the invites, these two, and they will accept. Choose two sequences, they choose the method that they want to use, and they can start the computation. As a first phase, here they are receiving the keys generated by the simulators, by both three simulators. And now they are ready for the computations necessary for the algorithm to run. So now here, basically, these two parties are communicating. At this point, these two parties are communicating, Alice and Charlie. And finally, Charlie and Bob are communicating. In the end, we get the same tree for all the parties. As you can see, this is Alice sequences, which basically, for example, Charlie does not have access to. These are Bob sequences, which Charlie does not have access to. And Charlie only has access to his own sequences. I hope you enjoyed, and thank you.